Hello everyone, Jen to all. Welcome to studio of Ajay Kumar Garg Engineering College, Ghaziabad. In this video lecture, I am going to discuss the next part of introduction. Before this video, we discuss what is the introduction of PDA, how we have to tell this is a language which is accepted by a PDA or not, and why we have to use for PDA. Here we are going to discuss a basic question that is called designing a PDA. How we have to design a PDA for a given language. That is the main point. And this is the main points where we have to discuss how a given language is designed for a given PDA. As we discuss, PDA are two types. The first one is deterministic PDA and second one is non-deterministic PDA. In case of deterministic PDA, we have knowledge about mid-value or mid-terms. But in case of non-deterministic PDA, there is no knowledge about mid-value or mid-term. So, first we have to identify which type of PDA we want to design. That is DPDA, deterministic PDA, or that is NPDA, non-deterministic PDA. After that, we decide what types of PDA we have to construct it. Or the PDA is accepted through final state or through empty stack. That is the two main question. Before designing the PDA, we have to ask yourself. In this part, we discuss two questions, one for through final state and second one for through empty stack. In case of final state, as we discuss, after processing the whole string, we reached on final state. The string or machine must be halt on final state. But in case of empty stack, the machine halt at any state, which may be final or which may be initial. But stack and input tape must be empty. So this is the two methods which is used to design a PDA for the given language. As we know, a given question, we have taken an example, design of the language, PDA of the language A power n, B power n, where n is greater or equal 0. This is a question for we have to design PDA. We can't design finite automata for this language because this language is not accepted by a finite automata. But this language can be processed or designed a PDA for the given language. The language is A power n, B power n, where n is greater or equal 0. We want to design a PDA for the language A power n, B power n, where n is greater or equal 0. Firstly, we think about which type of pattern this language is generated. If we want to write a language or a string for the given language, triple A, triple B. It is a language which is generated by it is a string which is generated by the given language. The number of A's is equal to the number of B's. But the basic condition is the number of A initially is equal to the number of B at last. This is the main part of this language. That means in initial number of A is 4, then at last the number of B is also 4. For this string, we want to generate a PDA or want to design, we have take an initial state. We start with initial state, that is Q1. We mark it entering arrow because this is a initial state. We know that we have to use input tape, finite control and push down store. What we can do in this question, the logic is that if A is encountered, we have to push inside the stack. That means the logic is that we have to match number of A's with number of B's. How we have to match? We match with help of the stack. First, we have encounter A, we have to push inside stack A. This is the bottom symbol, which is the initial symbol of the any stack which already pushes. First A is encounter, we have to push inside the stack A. Second A, then we have to push. Third, push like this. After that, we have encounter B. First, pop first A. First B pop first A. Then second B pop second A. Third B pop third A. After that, input null and top of the stack, we announce the machine to be accepted. This method is used to implement or design a PDA for the given language A power n, B power n. Look into the diagram. We have to take a initial state Q1 and entering arrow for initial state. Now, we have to use a loop. Loop means we want to push number of symbol on a single state. If A is encounter, we have to push inside the stack. Next A is encounter, push inside the stack. For this, we have to design a loop for continuous push. Input A, top of the stack Z0, A Z0. That means the basic condition. And the basic condition is like this. Top of the stack is Z0 and input of the stack is A. A is the input. We have taken this example, triple A, triple B. Input A, top of the stack Z0. We have to write here A Z0. That means here we have to push A on the top of Z. After that, again input A, top of the stack A. Now after pushing the A inside the stack, the top of the stack is A. Then input A, top of the stack A, we have to write double A, that means push again A. This statement is continuously executed. This statement is continuously executed. Whenever we have to A, next A, we have to push inside stack. Next A, we have to push inside the stack. All the A is pushes inside the stack by this statement. And this statement is executed a single time, first time. Whenever A is pushed inside the stack, this statement is stopped. This statement is execution is started. After number of A pushes inside the stack, now B is encounter. When B is encounter, we have apply pop operation. That means at the initially when A is encounter, we have to push, and when B is encounter, we have to pop. First B is encounter, the top of the stack is A, we have to perform here null, that means pop. We have to erase A. Null means we have to erase A. First A is erased. Now we have to repeat the loop because number of B is encounter and number of A inside the stack. For this, we can't change the state frequently. We have apply a loop that initially deleted all the content of stack. Next, B, input B, top of the stack is A, erase, we have to write here null. Same condition on state Q1. The number of B is erased with number of B. Second A is erased. Again this loop is repeated. Third A is erased. Whenever the input null, this one, at that condition, the top of the stack is Z0. We have to write here Z0 and move on a state Q2, and that state is marked as a final state because we want to design a PDA for a machine which have accept through final state. So that we have to mark this state as a final state. This is the main funda which is used to process the given string, and we have to design the given PDA for the language A power n, B power n. If we want to write transition function for this diagram, we can write easily. For how the state is Q1, we have to write delta state Q1, input, first input is A, top of a stack is Z0, The next state is Q1, and the operation is push operation. So we have to write like this, Q1 A Z naught. The next transition function is delta state Q1, input A, top of the stack A, the state is Q1 and here double A. This is the two operation for pushing the edge inside the stack. Now state Q1, input B, top of the stack A, we have to perform push a pop operation. Right here delta Q1, input B, top of the stack A, here we have to write state Q1. This is the state Q naught. State, this is the Q naught. This is Q naught. This is Q naught. This Q1, Q naught. Here Q1, state Q1, and here we have to write null. This is the pop operation. Again, here we have to repeat the same step. Delta state Q1, input B, top of the stack A. We have to perform state Q1 and null. This is the basic operations which is used for designing a PD. This is the last, that write like this, delta state Q1, input null, top of the stack Z naught. We have to write state Q2 and here null. If we want to accept through empty stack, otherwise here we have to write Z naught. There is no change in the top of the stack. Z naught is written as Z naught. This is the next question, or you can say the same question which is designed for empty stack. This is a question for empty stack. In previous part, we have to design the same question for final state, but here we have to design PDA for the empty stack. Before start this question, we want to clear what it mean by empty stack. In case of final state, after processing the whole string and at which state we have to halt it, that state must be a final. But in case of empty stack, after processing the whole string, we halted on final or non-final state, but stack must be empty. But previous case, it may be the stack content is not empty, but in case of empty stack, the state is also be empty. Look into this question. Same procedure. The language is A power n, B power n. We have taken a string A, B, 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 B. This is the 4 times A, 4 times B. This is the language which we want to design a PDA. And how we have to design the PDA in this part is, first we want to decide which type of string we want to accept. We have to take in 4 times A and 4 times B. In this part, same procedure we have to use. First, we have to push the number of A inside the stack. After A is pushing, we have to encounter B. And whenever B is encountered, we have to pop all the B from the stack. After that, at last, when input there is no symbol and stack is empty, then we declare the string to be accepted. We have taken an initial state that is called Q naught, and this stack mark an entering arrow for initial state. A self loop that is A Z naught is used for push the first symbol inside the stack. After executing this statement, we have to write like this. This is the initial condition. The bottom symbol is Z naught. Whenever input A, top of the stack Z naught, we have to push A inside the stack. First A is pushed inside the stack, here A. Now, the second statement is input A, top of the stack A /double A. The next is A is pushed inside the A. Third A is pushed fourth A is pushed like this. We have to push all the A inside the state by this statement. After pushing the all A's inside the stack, now when B is encountered, we start pop operation. In case of pop operation, first B is encountered, we have to perform top of the stack is A slash null. This operation is called pop operation. The first A is erase. Now state is Q1, we have to construct a loop and perform input B top of the stack A. Input B top of the stack A, we have to erase this symbol, next symbol. Next input B top of the stack A, erase next symbol. Next input B top of stack A, erase next symbol. The last symbol is input null and top of stack is Z0. This statement is executed. After executing this statement, input null top of the stack Z0, we have to erase this symbol. And after erasing, we reached on state Q1 and we declare this string is accepted. That means we have to construct a design of PDA which have the form of A power n, B power n, and n is greater or equal 1. Such type of string is accepted in case of finite automata or deterministic finite automata, but here we design a PDA for the given language so that we declare this language for A power n and B power n. We want to write transition function for this transition diagram. Same procedure we have to use to writing the transition function or transition function for the given transition diagram. Here the state is Q0, input A top of the stack Z0. We have to write delta state Q1 input A top of the stack Z0 equal to state Q1 comma A Z0. This means we have to push A inside the stack. Now the next transition function is input A top of the stack A, and we have to write double A. That means delta state Q1 input A top of stack A, we have to write state Q1 comma Q0 comma double A. This is the next push operation. Like this, we have to push all the operations, all the symbols inside the stacks. By using such type of stacks or such type of designing concepts, we have to design number of questions. Like we taken another example, that is W C W power R, where W belongs to A comma B. We want to design PDA for this language. What is the basic concept, what is the logic we have to use to design this PDA, PDA for the given language W C W power R. Think about this. Here C is the middle symbol. That confirms this is a deterministic PDA. That means the language middle term is identified, so that we have to use to design the concept of deterministic PDA. Before the C, we have a W, and after the C, W power R. The sequence before C is similar and reverse in W power R. So, before C, whenever A or B is encountered, we have to push inside the stack. We taken same procedure, but when A is encountered, we have to push inside the stack, or B is encountered, we have to push inside the stack. Or continuous A or continuous B is encountered, we have to push inside the stack. And so on, all the A and B is pushed inside the stack. When C is encountered, without the change of stack symbol, we move on next state. And after moving the next state, we have not perform any type of operation. After that, when C is encounter, there is no operation case is run. After that, the top symbol of stack is matched with W power R first symbol. The symbol which in W power R is must be matched with the top symbol of stack. That is the case of push operation. Means after C, we have to apply no operation and move on next state. When the first symbol after C is encountered, we have to start popping. And popping at that condition, when input A, top of the stack is also A, or input B, top of the stack is also B, this two case each decide to take the decision for apply the process or operation pop. Before this, we have to push. That means before C, we have to push, and after C, we have to pop. Whatever the symbol encounter, there is no meanings for symbol. Here, we have to push A as well as B before C is encountered, and after C, we have to pop A with B, A with A, and B with B, because W and W power R both are the reverse of each string. And by using these concepts, we have to pop or reverse the all string by one. This is the similar question like this. Like this, there are numbers of questions which have to discuss here. The first question is, now the next question is, we can use W power R. That is the case of NPD. W power R. That is the case of NPD. Here, the middle term is not identified. So, if any doubt or any question, you can message in the comment box. Thank you. Thank you for watching.